section 9.2, parabolas where the vertex is always at 0, 0. A parabola is defined this way. You probably haven't heard it explain this. A parabola is the set of all points equidistant, set of all points equidistant to a point and a line. So every point on the parabola is the same distance away from a point, and that point is known as the focus, and a line, which is different, and that line is called the directrix. So I'm going to draw a picture of what this looks like. So when you have so remember, everything, the vertex is at 0, 0 of the parabola for everything we do. And then we have to figure out, does it open to the right, left, up, or down? But the vertex is always at 0, 0 for now. So what it means is if there's going to be this focus point, and I'll call it F. It's a good name for it, F, focus point. And then there's going to be this directrix, and it's going to be either horizontal or vertical. It'll be horizontal if it opens up or down. This is called the directrix. And so every point on let me draw the actual graph now of the parabola is like this. So there's a parabola, there's a focus point and a directrix. So every point on this parabola, so I'm going to pick, for example, I'm going to just take this point here, hopefully it'll look right. I'm going to take this point E, I'm just going to call it E, and it has the coordinates x, y, because every point on the graph has a point x, y. So it means that this distance right here to the focus, the shortest distance, I'll call that D1, is equal to this distance, even though it might not look like it on my picture. It's the shortest distance to a line is the perpendicular distance. So D1 equals D2. And that would be true no matter where I picked my point. If it was, perfectly drawn, every single point is the same distance from the focus to the directrix. So that's the definition. And so now let me show you where this where the equation comes for it. So this distance from the vertex to the focus, we're going to call that P. So therefore the coordinates, what would the coordinates of this focus point be? If this is 0, 0 and this distance is P, it would be, good, 0P. And the directrix then is the equation in a horizontal line is always y equals a constant. Y equals a constant. And so what would it be? Y equals, if this distance is P as well, good, y equals negative P. Yes. And so then the coordinates of this point here, I'll just call this point, well, I won't name it, I just want the coordinates so I can prove something. If this drops straight down, what would I label the x coordinate here? It's the same as this, right? So this is just x, yeah. And then since the directrix is y equals negative P, then this distance away from this point is going to be y equals negative P. Why did I put that there? I'm going to have to go back and figure that out in a second. I have negative P here. Is that right?
Yeah.
Negative P. Okay, I think that's okay. Okay, this distance is P. Okay, so negative P, right. Yeah, it's the same as the line. Okay, so now let's we're going to calculate distance 1 and distance 2 and set them equal to each other because that's the definition of the parabola. And then we'll have our equation. So distance 1, we'll just use the distance formula. It's the square root. We're going to take the coordinates of these 2 points. The difference in the x coordinates, x minus 0 squared, plus the distance in y, y minus p, y minus p quantity squared. Everyone agree that's this distance, d1? I'm just using the distance formula. And then the second distance is the square root of the x coordinates subtracted, right? X minus x, that's just nothing, but we'll write it here. Squared plus the distance in the y is negative p. Y minus negative p squared. Okay, so we've got that, and so if we square both sides and set these equal to each other, see how the radicals disappear? So we just get this equals that. So we're gonna set d1 equal to d2 because they're the same, and square both sides. So the radicals will disappear and you'll get x minus 0 squared plus y minus p squared equals x minus x squared plus y minus negative p squared. This is going to simplify really nicely down into the equation for the parabola that we're going to be using. So this is just x squared, right? X minus 0 squared is just x squared. This, we're going to FOIL it out. Just do y minus p times y minus p. And so you would get y squared minus 2py plus p squared. So this whole, if you FOIL this, you would get this. If you just distribute twice, equals. This goes away. And this, if we FOIL this out, it's y plus p times y plus p, you get y squared plus 2py plus p squared. And now, nicely, conveniently, the y squareds cancel. The p squareds cancel on each side, and we're almost there. So if you subtract 2py from each side and combine like terms, you get x squared, well, so far we have x squared minus 2py equals 2py, right? So then you just, actually I want this on this side, so I'm going to add 2py to each side is 4py. Then there we are. This is it right here. That's where it comes from. X squared equals 4py. That's all you're going to use for whenever something is vertical. It opens up or down. So when it opens along the y-axis, the form you want is x squared equals 4py. That's what you'll be using today. The focus point is at 0p. Just like, because we drew that, that's how we defined it here. Focus is at 0p. And the directrix is at the equation y equals negative p that we defined right here. So this part is, these are the formulas for when it's vertical, and the formulas for when it opens, now this is new, when it opens right or left. So that's for vertical. And then for opening horizontal, if it opens along the x-axis, remember the vertex is always at 0, 0, and let's just say it opens to the right. So you have your focus point here and your directrix here, and they're both p away from the vertex. So this distance is p, this distance is p. And so then you would have this equation, y squared. If it opens along the x-axis, it's y squared equals 4px. And the focus would then be the coordinates p0, p comma 0, and the directrix would be, it's a horizontal line, vertical line, the directrix, so x equals negative p. It's always the opposite of p. So there are your equations. We'll break it into parts. We'll do 2 examples of what you're going to do first, and then we'll go to part 2. We'll save the rest. So you'll be asked to graph and find the focus and directrix. Graph and find the focus and directrix. We'll do 2 examples. We'll do this. We'll do y squared equals negative 6x, and then we'll do x squared equals 2y. Graph and find the focus and directrix. Okay. So since this is y squared, it opens along the x-axis. So I'm gonna write that because I need you to sketch a picture where we're gonna graph it. So opens along the x-axis. And does it open right or left? It's gonna open left because of this negative here. If it's positive, it'll go right. If it's negative, it'll go left. So it's gonna open left. So how far away is the focus and directrix? You just set 4p equal to whatever constant is here, because if you match this up with this right here, if you match these up, you just set 4p equal to the constant. So p equals negative 3/2 or negative 1.5. So the focus is p0. The focus is at p negative 1.50 from the formula, and the directrix is at x equals negative 1.5. So when we sketch it, our vertex is always at 0, 0. X equals negative 1.5 is somewhere over here. The focus is the directrix is x equals the opposite of p. I'm sorry about that. This is positive 1.5. It's the opposite of p. So otherwise my graph wasn't going to make sense. So x is over here, the directrix is over here at 1.5. The focus is at negative 1.50, and then you can just go like this to sketch it. You don't need any other points. Just graph the focus, directrix, and fill it in. So then for this one, since it's x squared, it opens along the y-axis. Opens along y-axis. And up or down? Up, because it's positive. 4p equals 2. So p is 1/2. So now you're using the other formula, which was here. So you're using x squared equals a constant. So the focus is 0p. 0p. The directrix is y equals the opposite of p. So your sketch will look like this. Y equals negative 1/2. It's about there. The focus is on the other side. It's always they're equidistant. And so then this is going to open wider. And there's your graph.